Chapter 5 States of Matter. First of all, what is matter? Anything which occupies space and has mass and volume is called matter. And matter exists in five states: solid, liquid, gas, plasma, and supercooled solids, or Bose Einstein condensate. Why do we call a substance solid? Because they have strong intermolecular forces of attraction, and due to which molecules are closely packed and they form a definite shape and volume. For example, in this, the diamond ring is a solid substance. It has a, a definite shape and definite mass. Next is liquid, in which the intermolecular forces are less than in solid, and the molecules are loosely bound with each other. For example, juice, water, etc. And they have definite volume but no definite shape. Next is gas, in which the particles are free to move and they occupy the maximum available space. And the intermolecular forces of attraction in the gas molecules are very weak. For example, clouds. And the next state is plasma state, in which a gas is superheated and it ionizes into ions and free electrons. That state of matter is called plasma state. And the last state is supercooled solids, in which when we decrease the freezing point of a substance, it crystallizes. When we decrease the freezing point, here it is water. When we decrease the freezing point of water, it crystallizes. And that state is called supercooled solids. Another example is of glass. It is also a supercooled solid. An example of plasma is lightning, neon signs, in which a gas, neon is a gas which is superheated and it ionizes to form ions and free electrons. And all these states are interconvertible. Solid changes to liquid when we provide heat energy, and the process is called melting. And liquid changes to gas, the process is called vaporization, and the gas changes to plasma, and the process is called ionization by providing the heat energy. And on cooling, the reverse process takes place. Plasma changes to gas, deionization occurs, gas changes to liquid due to condensation, and liquid forms solids due to freezing. If we heat the substance, the state of the substance changes, and this is a reversible process, convertible as well as a reversible process. Intermolecular forces. These are the forces of attraction which exist among the molecules of a substance. For example, In case of water molecule, this is the intermolecular force, which binds the two water molecules together. There are various types of intermolecular forces which exist among the molecules. For example, number one is dipole-dipole interaction, ion-dipole interaction, then ion-induced dipole interaction, dipole-induced dipole interaction, then dispersion forces or London forces, and the last one is hydrogen bonding, which exists among the water molecules. This is a type of intermolecular force. First type of intermolecular force is dipole-dipole interaction, which exists among the polar molecules. Polar molecules are those which form dipoles. Means, and these dipoles exist due to the electronegativity difference between the atoms. For example, HCl. It is a polar molecule because in this molecule the chlorine is more electronegative than hydrogen, and it pulls the electrons of the bond towards itself, and that's why it acquires partial negative charge and hydrogen acquires partial positive charge. And the attraction between Cl negative and H positive is called dipole-dipole interaction, in which two HCl molecules are bonded with the dipole-dipole interaction. This is the dipole-dipole attraction because here two HCl molecules form two dipoles. These are two dipoles, and the negative charge attracts the positive charge, and the type of attraction is dipole-dipole interaction, and these are permanent dipoles in HCl. Next is ion dipole interaction. It is the attraction between an ion and a polar molecule. For example, hydrated cation. This is an example of hydrated cation in which a sodium ion, this is the sodium cation, which is surrounded by water molecules. These are water molecules, and these red spheres represents the oxygen, and it carries partial negative charge, and hydrogen carries partial positive charge. Here in the center, as you can see, this is the cation, means which loses its one electron and acquires a positive charge, that is Na positive, and this positive charge attracts the negative charge of the oxygen of water molecule, and this forms the ion dipole interaction. Here positive and negative charge of water are the dipoles, and Na positive is the ion, which forms a attraction between an ion and a polar molecule. Water is a polar molecule. If we dissolve NaCl in water, it forms hydrated ions. First one is of sodium, in which oxygen surrounds the Na positive ions. And the next is chloride ion having negative charge, in which the H positive of water surrounds the chloride ions, like this. Here, these are H positive, which surrounds the chloride ion. Here it is negatively charged, and this negatively charged chloride ion is surrounded by positive charge of water molecules, and this is the hydrated anion, and this is the hydrated cation. When we dissolve sodium chloride in water, it dissociates into water, and the water molecule surrounds the separate ions Na positive and Cl negative, and these are called hydrated ions, and the process is called hydration. Next type of intermolecular force is ion induced dipole interaction, in which an interaction between ion and induced dipole. What is induced dipole? A non-polar molecule which is polarized by presence of an ion near it, that is called as induced dipole. A small distortion of electron cloud occurs, due to which it acquires partial positive and partial negative charges. For example, in case of Fe2 positive and O2 molecule, if this Fe2 positive approaches towards the oxygen molecule, it get polarized. This oxygen acquires partial negative charge, and the second one acquires partial positive charge, and the attraction between positive and negative charge is called ion induced dipole interaction. And another example is of NO3 negative and I2 molecule. Suppose this is I2 molecule. Here it is NO3 is negative. When it approaches towards the iodine molecule, it get polarized. It is a non-polar molecule. It get polarized and acquires partial positive charge, and the second one acquires partial negative charge. The attraction between positive and negative charge is called the ion induced dipole interaction.